Welcome to Bethel Online Education Hub. Learn anytime, anywhere. Don't forget to like, comment, share, and subscribe for more. Let's learn together, the Bethel way.
Hello everyone. Welcome for today's lesson on endogenic processes. We're going to explore the natural forces that come from inside the earth. The word endo means within, and genic means originating from. So, when we talk about endogenic processes, we're referring to the powerful movements and changes that happen beneath the Earth's surface, shaping and forming the world we live in today. Deep under the ground, the Earth isn't just made of solid rock. It has layers of hot, moving, and sometimes molten materials, like the mantle and the outer core, under extreme heat and pressure. These conditions cause the tectonic plates to slowly move. As these plates move, they create powerful internal forces. These forces can push, pull, or slide the rocks around, causing parts of the crust to rise, fall, bend, crack, or shake. And even though these forces start deep underground, their effects eventually reach the surface, leading to the creation of mountains, valleys, volcanoes, and earthquakes. Before we begin, it's important to understand that the Earth isn't just a solid, still ball of rock. Beneath our feet, our planet is made up of different layers, some solid, some molten, and all under intense heat and pressure. These extreme conditions cause powerful forces to build up inside the Earth, leading to movements and changes that shape the very surface we live on. In today's lesson, we're going to focus on these internal movements, which scientists call endogenic processes. These natural processes play a major role in creating landforms like mountains, valleys, volcanoes, and even causing earthquakes continuously reshape our planet in powerful and sometimes surprising ways. So, what exactly are endogenic processes? In simple terms, endogenic processes are geological phenomena that originate beneath the Earth's surface. The word endo means within, and genic means originating from. So, when we say endogenic processes, we're talking about natural activities caused by forces inside the Earth. These forces, also called endogenic forces, are driven by intense heat from the Earth's core, immense pressure from overlying rocks, and the movement of molten rock, or magma, deep within the Earth's mantle. So, these forces are always working beneath the surface. We usually notice their effects only during dramatic events like earthquakes, volcanic eruptions, or when entire mountain ranges slowly form over millions of years. But whether they happen suddenly or gradually, endogenic processes play a crucial role in shaping our planet. They are responsible for creating landforms such as mountains, formed when tectonic plates push against each other; volcanoes, when magma escapes through cracks in the crust; valleys and rift zones, where land sinks or pulls apart; and of course, the powerful shaking of the ground we feel during earthquakes. So, as we move forward in this lesson, keep in mind that even though we can't see them, these hidden forces beneath our feet are constantly at work, slowly changing the face of the Earth. Now that we know what endogenic processes are, let's talk about what happens when these forces act on the Earth's crust, push against the crust. They can cause it to break, bend, twist, or shake. These movements aren't always visible to us right away, but they are happening deep underground, constantly reshaping the land we live on. This movement affects the different layers of rock beneath the surface. In some cases, the rocks are slowly pushed together or pulled apart over millions of years. Other times, the pressure builds up so much that the rocks crack and suddenly move, causing events like earthquakes. These dynamic movements and changes in the Earth's crust are part of what we call endogenic processes. They are responsible for the formation of huge landforms like mountain ranges, valleys, rift zones, and volcanoes, shaping not only the land we see today, but also determining where future landforms might appear. Now that we've talked about how endogenic forces move and shape the Earth's crust, let's focus on the two main processes that cause these movements. These are called folding and faulting. These processes usually happen along plate boundaries, the edges where huge slabs of the Earth's crust, called tectonic plates. As these plates slowly move because of the intense heat and pressure inside the Earth, they create enormous stress on the rock layers above them. Depending on how the rocks react, they either bend or break. Folding. First, Let's talk about folding. This happens when two forces push rock layers towards each other. But instead of cracking, the rocks bend into wave-like shapes. This usually takes place under conditions of high temperature and pressure, where the rocks become flexible and can slowly bend without breaking. When this happens, we see two types of folds. Anticlines, these are the upward arching folds, like the peak of a hill. Synclines, these are the downward, trough-like folds, like a dip or valley. Over millions of years, this process can create mountain ranges, such as the famous Himalayas, which were formed by the collision of the Indian plate and the Eurasian plate. Faulting. Show image of a fault line or rock layers breaking. Now, when rocks are too brittle or the stress is too sudden or intense, instead of bending, the rocks break and move along cracks called fault lines. This is what we call faulting. The movement along these faults can happen in different directions: upward, downward, or sideways. And depending on the kind of stress applied, we get different types of faults. 1. Normal fault. 2. Reverse fault. 3. Strike-slip fault. These faults can cause powerful earthquakes and create major landforms like block mountains and rift valleys. Now that we understand what faulting is, when rocks break and move along cracks because of strong internal forces, let's take a closer look at the different types of faulting. There are 3 main types of faults, and each one happens because of a different kind of stress or pressure acting on the Earth's crust. Let's go through them one by one. First, we have the normal fault. This happens when tension forces pull the Earth's crust apart. As the rocks stretch and thin out, one block of rock moves downward compared to the other. This creates valleys or low-lying areas between higher blocks of land. Rocks are pulled apart, and one side drops down. Example: the famous East African Rift Valley was formed by normal faulting as the crust in that region continues to pull apart. Next, we have the reverse fault. This is the opposite of a normal fault. It occurs when compression forces push the rocks toward each other. When the pressure becomes too great, one block of rock is forced upward over the other. Rocks are pushed together, and one side moves up. Example: parts of the Himalayas were formed by reverse faulting as the Indian plate pushed against the Eurasian plate, causing massive uplifts and mountain formation. Finally, we have the strike-slip fault, also known as a tear fault. In this type of fault, shearing forces cause the rocks to move sideways past each other. There's very little upward or downward movement. Instead, the crustal blocks slide horizontally. Rocks slide sideways past each other. Example: one of the most famous strike-slip faults in the world is the San Andreas Fault in California, where powerful earthquakes often occur. Now that we've learned about the types of faulting, let's find out what happens on the Earth's surface because of these powerful movements. When rocks in the Earth's crust break along faults and move, whether it's upward, downward, or sideways, the land doesn't just stay still. These movements can create large, noticeable landforms that we can actually see and visit. Let's talk about 2 of the most important landforms created by faulting: block mountains and rift valleys. First, we have block mountains, also called horsts. These landforms are created when land between 2 faults is pushed upward because of compression forces. As the pressure from the Earth's interior builds, huge blocks of land get forced up above the surrounding areas. They have steep sides and flat or slightly sloping tops. You'll find them surrounded by lower-lying land. Examples: the Sierra Nevada mountains in the USA and the Vosges mountains in France are great examples of block mountains formed through faulting. Next, we have rift valleys, also called grabens. These form when land between 2 parallel faults drops down because of tension forces pulling the crust apart. As the crust stretches and thins out, the middle section sinks, creating a long, narrow valley. They are typically long and narrow. Often, they are associated with earthquakes and volcanic activity. Famous example: the East African Rift Valley is one of the largest and most famous rift valleys in the world. It stretches across several countries in Eastern Africa and is still slowly pulling apart today. Now that we've covered folding and faulting, let's talk about other important geological processes that also come from deep within the Earth. These are called subsequent endogenic processes because they often happen alongside or after folding and faulting. The three major ones we'll focus on are volcanism, metamorphism, and earthquakes. First, let's talk about volcanism. This process happens when magma, which is molten rock from beneath the Earth's crust, moves up to the surface. When folding or faulting weakens the Earth's crust, it creates openings and cracks. Magma, which is less dense than the solid rocks around it, rises through these cracks. When it reaches the surface, it erupts as lava, ash, and gases. What happens next? The lava cools and hardens, creating new landforms such as volcanic cones, tall, cone-shaped mountains; volcanic plateaus, wide, flat areas from large lava flows; and igneous rocks, which form when lava solidifies. Example: Mount Mayon in the Philippines is one of the world's most perfectly shaped volcanic cones. Next, we have metamorphism. This is when existing rocks change form because of intense heat and pressure, but without melting into magma. How does it happen? Deep underground, especially near tectonic plate boundaries or beneath mountains, rocks are subjected to extreme heat and pressure. The minerals inside those rocks rearrange and form new types of rocks. Examples: limestone changes into marble. Shale changes into slate. This process recycles old rocks into new forms and helps reshape the Earth's crust over millions of years. Finally, let's talk about earthquakes. An earthquake is a sudden shaking of the Earth's surface caused by the release of energy along a fault line. How does it happen? Tectonic plates are constantly moving, but sometimes their edges get stuck. As the plates continue to push, pull, or slide, pressure builds up. When the pressure becomes too much, the rocks snap and move suddenly, causing vibrations we feel as an earthquake. Did you know? Some earthquakes are also caused by rising magma beneath volcanoes, especially before an eruption. Alright, let's quickly review what we've learned today. We explored the powerful forces called endogenic processes, which come from deep within the Earth and reshape the surface we live on. We covered folding and faulting, the two main processes that cause rock layers to bend or break, forming landforms like mountains, valleys, block mountains, and rift valleys. Then we looked at the subsequent endogenic processes. Volcanism, where magma rises and erupts, creating volcanoes and new landforms. Metamorphism, where existing rocks are changed by heat and pressure into new types of rocks. And earthquakes, sudden ground movements caused by the release of built-up pressure along fault lines. Each of these processes shows how our planet is constantly active, sometimes changing the land slowly over millions of years, and other times causing dramatic, powerful events we can witness in our lifetime. I hope today's lesson helped you understand how mountains, valleys, volcanoes, and earthquakes are all connected through these internal Earth processes. By learning about endogenic processes, we not only gain knowledge about how our planet works, but we also become more aware of the natural hazards around us and the importance of protecting our environment. Thank you so much for joining me today. Don't forget to review your notes, and check out our next lesson where we'll explore exogenic processes, the forces that shape the Earth from the outside. See you next time, everyone.